this is the question that I gave to you just now, and I already sent the answer in what was it? Notes and resources. So basically, this one is already a very nice quadratic equation that is already complete the square for you already. So you know your vertex is -2, -9, right? And then it should be something like this, and then you just draw your parabola until here. Sorry, not here. Until here, this is your vertex, and then go out a little bit. Then after that, this is a straight line. This is straight line, and I think, if not mistaken, it is a -5, and then it should pass through like that. Okay. So it is a parabola. Okay, it is a parabola, and then becomes a straight line. Okay. Then after that, the range is obviously from this one, the minimum. The minimum of it is -9. So it's from -9 inclusive to +infinity. And this one, whether it is a one-to-one function. Okay, no face, never mind. Okay, whether it is a one-to-one function, whether it is injective, you just draw your horizontal line test. You see, you have more than one intersections, so no. Okay, and the answer is already in the notes and resources page. Okay, so now we'll proceed with the second section, which is, yeah, it's okay if you guys can see my face. Something wrong with my laptop. Okay, we'll proceed with the second part of the chapter, which is polynomials and rational functions. So polynomial functions, I believe you have seen this in your Form 4 Chapter 9 differentiation, when you learn about power bring down power -1. That one is for derivative for polynomial function. So basically, polynomial function is like you have like x squared plus 2x plus 1, or x cubed plus how many maybe x squared plus maybe -5x plus 4 or something like that. Then x4 blah blah blah. As long as all the powers, okay, all the powers here are integer. Okay, are integer. Okay, they are all integer. And then you have this one, this an -1, an -2. This one, all the worms are just constants. Okay, they are just real constant. They can be fraction. They can be like they can be irrational. Like they can be pi. They can be e. They can be anything, as long as they are real. As long as they are not I. Okay. So polynomial functions, we usually have like, what you need to know is actually the degree of polynomial. The degree means it is the highest, is the greatest power of x in that function. Okay, because they are all integer, so usually people will arrange it like in descending order. You write the greatest power of x at the very beginning, and the power decrease eventually. Okay, and yeah, this you have two examples here. The degree of the first graph is actually 4. This is a degree. And the degree of the second function, you may say, oh, maybe a little bit complicated, but don't worry, you just go ahead and focus on x. You see, x raised to the 4th power times x raised to the 3rd power. Okay, so a little bit. Okay, so you have, if you go and open up this bracket, okay, I just want to know the degree. You have x to the 4th power here. You have x cubed here. You have another x here. Your indices, you go and combine, you go and add out the powers, right? 4 plus 3 plus 1 is what? 8. So the degree of this graph, the degree is 8. That's all you need to know about polynomial function. And another fact you need to know about polynomial function is that, because polynomial function is not like, I told you that the power have to be integer. So you will not have something like this, which means the square root of something, which means you don't have to worry about, oh, this cannot be negative, or you don't have to worry about, oh, 1 over x, because this is x -1, right? Non-negative integer. So you don't have to worry that you will get a 0 in denominator. You don't have to worry that you will get a negative inside a square root. Hence, the natural domain of any polynomial function is from -infinity to +infinity. It's throughout the entire number line. That's all. Next, we go to division of polynomial, which is I think is the hardest part in the whole chapter 1. Okay, But before that, we do something very easy first, which is like division. Yeah, you have this is what you do in the primary school, isn't it? So yeah, I want to find what is the answer for 166 divided by 5. But usually people don't write that in. I believe at your level, I think it's very rare for you to write this symbol even. Right? So usually people will write 166 divided by 5 like that. Right at your level, it's like looks more elegant, more standard. Okay, but what is the value? If let's say you can't use a calculator, try about your calculator. You cannot use calculator. How you calculate back then in primary school? Remember, once upon a time, you're going to draw this kind of thing. You put your 166 inside. You put your 5 outside. Right? And then what you do? 5 times 3 is 15. And then what? Minus, right? 16 minus 15 is 1. Then bring down the 6 is 6. 5 times what? 5 times 3 again is 15. And 1. And 5 times what can give you 1? No more, right? Unless you want to go decimal. But I will just stop here. This is the remainder. This is the quotient. And if you notice, this is actually the numerator. This is actually the denominator. Numerator, denominator. So if you still remember what you learned in your primary school, this is what we call improper fraction, isn't it? You can write it in mixed number, which is 33 and a 1 over 5, which is 33 plus 1 over 5. Which means that whenever you have a numerator divided by denominator, the definition of division basically is like you have your numerator. Sorry. This is your quotient. Your numerator divided by denominator is actually your quotient plus this is your remainder over what is this? Your denominator. One more time. Numerator divided by denominator is quotient plus remainder over denominator. Okay? You should know this. You should know this by now. Okay, now we try to extend this idea a little bit, right? So back then you only learned about division of numbers. Now we want to learn about division of polynomials. And I told you that this is the definition of division. It's always numerator divided by denominator is quotient plus remainder over denominator. So what if I want to divide this further here, x cubed plus 2x plus 1. I want to divide it by x minus 2. What should I do? I tell you, it's exactly the same thing that you'll do here, just a little bit different, just that you have your x and x squared, x cubed, everything comes in. So this method is what we call as long division, okay? You see, you just follow a pattern. Just follow a pattern. You draw this one first. Draw this one. I don't know what does it call, like maybe a pistol or a gun or whatever. Then you put what inside? You put your numerator, isn't it? You put your numerator inside. X cubed plus 2x plus 1. Take note, I leave a space here for a reason. You'll know why. Just leave a space, okay? Then, what should you put outside? What do you put outside? The denominator, isn't it? Who is our denominator? X minus 2. Okay? And the reason I leave a space here is if you notice for this polynomial, you have x cubed, you have x, you have this actually x to the 0, but actually you don't need to write it because it is just a constant. You don't have x squared, right? So you better when you do your long division, you better do not confuse yourself. You better write a 0x squared here. And it's also to make your work more organized. But of course, when you are more familiar with long division, you don't have to write it. Just when you just start to do long division, or if you want to make your work more organized, make sure at least you go and leave a space for x squared. Okay? And now what you do? Don't worry. Come back to this one. Yeah? How did you get 15? It is 5 times 3, isn't it? 5 times 3 is 15. Why do you choose 3? Why not 5 times 2? I put a 10. I put a 10 here. Then 16 minus 10, I get a 6. Or why don't I choose 4? I get a 20. Or cannot, minus you get a negative, right? Okay, why do I choose it? Because I want to get rid of as much as possible from this 16, right? I want to get rid of as much as possible. Okay, remember that? Take that in mind. So now, if you have a look at this one, this polynomial, and in fact any polynomial. Let me give you an analogy. 2 cube and 2 square, which one is greater? 2 cube is definitely greater, right? If 2, what's that? 2 to the 4th power and 2 to the 3rd power, which one is greater? This one, right? So, or 3 to the 4th is always greater than 3 to the 2nd power, something like that. So, you see here, as long as your base is the same, the greater the power here, the greater the number itself. Same thing, if it is x, okay, for now you just, because it is not 100% true. If your x is like fraction, then it is different story already. But now I just want you to get the idea that x cubed is the greatest thing that you want to get rid of from the denominator for now, for the first step of your division. So you need to multiply something. To x minus 2 to get rid of x cubed. One more time. You need to multiply something to x minus 2 to get rid of x cubed. You don't care about minus 2, and you don't care about 0x squared plus 2x plus 1. Just focus on x cubed. You want to get rid of x cubed. So if I have x minus 2, I want to have an x cubed. How should I multiply? X squared, isn't it? So if I multiply this up, what do I get? X cubed minus 2x squared, right? So what you do here, you see, 5 times 3 is 15. Where do you write the 3? Where do you write your 3? This one is your 3, this one right here, right? So just write this one. Just follow on top. You have just write your x squared. Where should you write your x squared? You should write it on top. And okay, the reason excuse me, the reason why I want to write a 0x squared here is I want you to align all the power. So you can write x squared this one nicely on top. And where did you put your 15? Where do you put your 15? Here, right? So this one you put here. X cubed minus 2x squared put here. Next, what you do? How you get your, okay, how you get the 1? 16 minus 5, isn't it? So you go and minus. Okay, maybe I should erase this one. Okay. Minus, follow me closely, x cubed minus x cubed is 0. 0x squared minus x, 2x squared is positive 2x squared. Okay? Okay, I start over again, okay? First, you put your numerator inside, put your denominator outside. You want to get rid of x cubed. So I multiply x squared to my denominator so that I can get the x cubed. Then, following this pattern, 5 times 3 is 15. I put my 3 on top. So I put my x squared on top. I put my 15 here. So I put my x cubed minus 2x squared here. Then I use 16 to minus 15, right? 16 minus 15. So I use this one. X cubed plus 0x squared minus this x cubed minus 2x squared. Then now you get a 2x squared. But this is not the end. Continue. What you do? You see what you do here? You bring down the 6, isn't it? Same thing. You will bring down the next term, which is 1 degree. Okay, maybe I shouldn't call it degree. The power is 1 less than x squared. Okay, so plus 2x. Now, again, it's the same story again. What should I multiply to x minus 2? What should I multiply to x minus 2 so that I can get rid of 2x squared? You don't care about 2x. Don't care about don't care about this one. This one is the This one is the big brother, this one is the small brother. You don't care about small brother first. You want to defeat the big brother. You want to get rid of the big brother first. So this one is pretty obvious already. X minus 2. You multiply with, you need another x. Right? So that when you expand, you get the x squared. And you also need a 2 in front of your x squared. So when you expand, you have 2x squared minus 4x. Same story. Put your 2x on top. Put your 2x squared minus 4x here. Oh, just okay, I forgot plus. It's a positive 2, right? I multiply with positive 2, right? Okay, then we'll do what? Minus. See, the big brother, we get rid of the big brother. 2x squared, get rid of it. 2 minus 4 becomes 6x. What you do? Bring down the 1. Okay? Then now tell, oh, I know. I want to get rid of 6x. I want to get rid of 6x. What should I multiply with? Just a 6. Huh? So what's that when I expand? It's 6x minus 12. Where should I put my 6? Positive 6 on top. Where should I put my 6x? 6x minus 12. Here. How should I do? Minus 6x cancel each other. 1 minus 12 means 1 plus 12 means 13. Okay? And now what? Is it possible for you to multiply x? What can you multiply to x minus 2 so that you can get a? And another thing is that whatever you multiply here must also be x raised to a non-negative integer. Which means that's it. You cannot continue anymore. And this is your remainder. This is your quotient. This is your numerator. This is your denominator. Yeah, I know this is very new to you. I know this long division is very new to you. So yeah, I will repeat again. It's actually exactly the same concept as the division that you have done in your primary school. First, put your numerator inside, your denominator outside. Next, you multiply x minus 2 with something so that you can cancel out with x cubed. And in our case, we multiply with x squared, and I will put our x squared on top. Whatever you multiply this and that, you get this. You just put here. Okay? And then follow your primary school division, you minus, so that you can get rid of x cubed. After you minus, okay, you have 2x squared, right? What do you need? Okay, and you also remember to bring down. You remember one term. Only bring down one term. Don't bring down everything together. Okay, don't bring. It's like you have if you have 16666 divided by 5. Okay, times 3 15. You don't bring down all the 6 at the same time, right? You don't do this. Okay, you only bring down 16. You only bring down 16. So you only bring down the next term. Clear? Then after that, you do the same thing. What should you multiply to x minus 2 so that you can get rid of 2x squared? 2x. 2x put on top. Whatever you multiply, put here. Then minus. To get rid of your 2x squared. Then same story again. Minus, after you minus, you get 6x. Put down another fella. Do the same thing. Multiply with 6. 6 put on top. Whatever you get, put here. Minus. Until you cannot continue. And that is a remainder. Is long division okay for you guys? So far okay? For long division? If okay, then type of okay in the general text. Well, because I understand this one is like a completely new thing to you. Okay, Polly say okay. Yes. Take your time to digest. Okay, I don't think I can turn on my cam, so yeah, never mind. We already took our group photo, so it's okay. Okay, so that is this is long division, but this is not all. Remember, just now we established that numerator divided by denominator. Numerator divided by denominator is quotient plus is quotient plus remainder over denominator. So if you like, you can also write this x cubed plus 2x plus 1 divided by x minus 2. You can also write it as quotient. Who's your quotient? X squared plus 2x plus 6, isn't it? This is your quotient. Okay? Plus remainder. Who's your remainder? 13. Over, who's your denominator? X minus 2. And that's it. This is the procedure of long division or division of polynomials. Okay? Let's do one more time again. Okay, we do it again for this long division. I do it again. But this time I don't write all the x squared. I don't write all the x squared. Okay. I think I get rid of this part. Okay. I do it here. This time I don't write all the x squared, x cubed so that you don't confuse. I just write the coefficient. The coefficient of x cubed is 1. Coefficient of x squared is 0. Coefficient of x is 2. Coefficient of x to 0, which is the constant, is 1. Okay? And now, what about this one? The denominator. Coefficient of x is 1. Coefficient of the constant is, okay, the coefficient of x to 0, which means the constant is negative 2. And now you imagine, I told you that this is the big brother, this is the big brother, this is the little brother. When you want to fight the boss, you ask your little brother to hide the back. You are the big boss. You are the big brother. You go fight the boss. Okay? So 1 times what? Okay, your boss is now 1. This is your boss now. 1 times what will kill the boss? 1 times what will give you a 1? 1, right? Just write a 1 on top. And then 1 times 1. Okay, 1 times 1 is 1. Okay, after you defeat the boss, after you kill the boss, you have like treasure, you have like, you can eat the boss, you can have the meat, right? Okay, you can have your party. And that is the time you call your little brother. Call him, hey brother, come. We eat the boss together. We eat this bear or tiger or whatever monster. We will cook a boss. So 1 times negative 2, 1 times the little brother is negative 2. Then after that, after you kill the boss, after you all eat the boss, you need to shit, right? You whatever you eat, after you eat, you are shit, right? So minus what is left? You see? 1 and 1 will get off each other, will cancel out each other. 0 minus minus 2 will be positive 2. And the next day, you bring another little brother. You bring another little, same little brother. The big boss bring his little brother. This is your little boss. Okay, your little boss come down. The boss come down. So now, you are still the big brother, right? You are still a big brother. You are still the one. You need to get rid of this big boss, 2. So 1 times 2 is 2. After you kill the boss, ask your little brother come to eat together. 2 times negative 2 is negative 4. This one, I get rid of this one first. And then, after you eat, you shit again. 2 minus 2 is 0. 2 minus 4 is 6. Another new boss, bring down his smallest brother. His youngest brother, bring down the 1. Big brother, go fight the boss. 1 times 6 is 6. 6 times negative 2 is negative 12. What you do? After you defeat the boss, you eat the boss and you shit. 13. Do you notice that this is exactly the same thing as what we did here? And this is just the coefficient of x squared plus x plus the constant, and this is the remainder. So at the end of the day, this one, x cubed plus 2x plus 1 divided by x minus 2 is equals to x squared plus 2x plus 6 plus 13 over x minus 2. This is what? Quotient, remainder, denominator. Finish. And this is the story of long division. Okay? And now, oh, it's 4 o'clock already. I'm really sorry we are behind the schedule. Maybe we have to drag until 5 because we still have partial fraction better. Okay, now I will show you oh, by the way, don't ever do this in your exam. Don't ever write this in your exam. Your teacher will never understand. I also not understand. Okay, don't write this in your exam. Write this. This is the proper working to give you the full marks. But now I just show you another way for you to check your answer. And I'm not sure if your teacher will teach you this. This is what we call synthetic division. Okay? So what you do is very simple. The same thing, you still need to determine the coefficient for all the how's that, your numerator. So it is 1, 0, 2, 1. Am I right? Then you go and draw an L shape. And then you focus on this one. X minus 2. You compare it with X minus C. Compare it with X minus C. So who is your C? Your C is 2, isn't it? Put your 2 here. How you do? First step, bring down the 1. Write your, okay, maybe I shouldn't use it. Okay, bring down the 1. Write your 1 here. Next, 1 comes here. 1 times 2 is 2. Okay? Again, 1, bring down. Right here. 1 times 2, come here. Write the 2 here. Okay? And then now what? Just now you minus, right? Just now you minus because of what? Because this is minus 2. But now we are positive 2 here. So you plus. 0 plus 2 is 2. Okay? 2 times 2 is 4. Okay? Then 2 plus 4 is, okay? Then 6 times, is it my noise? Okay. 6 times 2 is 12. 1 plus 12 is 13. And then you go and look at the you draw a line here. Okay? Do you notice that this is also the coefficient of x squared, x, and x0, and this is a remainder? So this also tells you that this is x squared plus 2x plus 6 plus remainder over denominator. So this is by synthetic division. Basically, you just write down all the coefficient. Your C here, I will tell you what is C later after we talk about remainder theorem. Your C here, first step, bring down right here. Then this times that, bring here. This plus this right here. This times this, bring here. And then this plus this right here. Times 2 right here. Plus together. 1 plus 12 together 13. Okay, so this is synthetic division. But don't worry, we will have more exercise later that we need to use synthetic division. So basically, this one is just for you to check your answer because I don't think this will give you full marks for your working. It's like too simplified, you know. It's like this is actually back then when I did my C++ programming project, right? When I want to do the division of polynomials, this is actually the algorithm that I use. Okay, so sometimes it's important for you to know the real idea of real division, which is this fella here. This fella here, you have to know this one. Instead of just knowing the technique or the shortcut method like that. Just like your differentiation. You have learned your first principle, everything in your Form 5, right? But if all you know about differentiation is bring down the power minus 1, you are going to die when you go to semester 2. When you need to differentiate sine, when you need to differentiate cos, when you need to differentiate logarithmic function, all the log. You say, hey, where is the power? Where should I bring down the power? GG. So you need to really go and understand the idea behind long division before you use this kind of shortcut method. Okay, same thing for a differentiation. You need to understand what is differentiation, what is the first principle, the delta x, delta y, the small change in x, small change in y, so that you will be more comfortable, you will be more prepared when you need to differentiate weird function like or the trigo function or the log function. Okay, so this is a moral of the story. Next, we go to the next one, which is Remander theorem. And Remander theorem is actually from the it's actually the same from our long division, the story of long division just now. Okay, so consider a function, this one x cubed plus 2x plus 1. Then find the value of f of 2. Yeah, just sub in. This is 8 plus 4 plus 1, which is 13. Do you notice that this is actually a function from just now? So messy already. This fella here. Okay. Yeah. Do you notice that it is this fella here? And do you notice that this one is this one? And do you notice that this 13 is the remainder? So what can you conclude? What can you conclude? What can you conclude about this 2 and just now we divide fx by x minus 2, right? So this is here comes to where is our remainder theorem, but this long shit you don't have to read. I just tell you the story in short. Okay, so by the definition of division from just now, we say that whenever you have something fx, then you divided by okay. Now I focus on linear factor. Now I focus on linear factor. In real deal, you maybe sometimes you need to divide by a quadratic factor or cubic or whatever. Okay, let's say it is x minus c. Okay, you divide by x minus c. What do you get? Numerator divided by denominator, you get quotient. Quotient, and because this time with quotient we have is actually a function. It's actually a function because we have all the x, right? So you have all the x. Quotient, so I say quotient x is a function of x plus the remainder over x minus c, isn't it? Remainder over denominator. And now I multiply both sides. Okay, multiply both sides by x minus c. Okay, I get fx equals to x minus c times qx plus r, right? This x minus c and this x minus c cancel out each other. And what happened? What happened when I substitute c to my x? Okay, what is f of c? It is c minus c times q of x plus r. C minus c is 0. 0 times anything is 0. So f of c is r. And this is your remainder theorem. Okay? Basically, if you divide fx by whatever gx, okay, I try to further generalize this idea. When you divide fx by gx, okay, you will get a quotient x plus remainder. Okay, sometimes remainder of x, this one means what? Means sometimes your remainder is not necessarily only of constant. Sometimes it is also in terms of x over the denominator, right? So the remainder of this one, okay, the remainder of this one is exactly the same when you substitute in your c. One more time, look at this example, yeah? Your c, I told you just now, your c is 2. Your c is 2. Your c is 2. When you find f of c, when you find f of 2, you get 13, which is the remainder, when you divide your function fx by x minus 2. Finish. That's the story of remainder theorem. Okay? So yeah, I have another question for you. This is a partial question, and Yeah, you actually, okay, I just give you a direction and you can try on your own. Basically from here, you see you remainder of 4 and divided by x minus 1. Which means when you find P of, who's your C? C is 1. It's going to be 4. Remainder of negative 2. Who's your C? P of negative 1 is negative 2. And this one you have, like, you go and form two simultaneous equation. You have your h and your k. You solve your simultaneous equation. You put it back. Get your px. This is the first part. Okay. Then after that, this is actually long division, right? You just divide your this one px divided by this x squared is 1. And you see, I told you your denominator is not always a quadratic factor. And for this question, I recommend you to do the long division. Don't do the synthetic division because it will cause you headache. It will cause you headache because of the x squared here. Okay? Then after that, you get your this one, you get your this one. And the question very nice, I already tell you that this is a quadratic, this is a linear. Then after that, you solve for the inequality. Okay? Yeah, I will send you the answer after the class. Just if you have time, you can try it on your own. This is a past year question. Okay, and now we go to the factor theorem. And factor theorem is actually a special case of Remander theorem, or you might also call it an extension from Remander theorem. So first we consider a quadratic equation. This one. What happens when you divide this function by x plus 1? Which one do you prefer? Do you prefer long division or synthetic division? I think for this one we do long division. Okay, we do long division. Divided by x plus 1. I need 2x squared. So I multiply with 2x. 2x squared plus 2x. What I do? Minus 3 minus 3 minus negative 2 is negative 5. X minus 5. And it's a negative 5 times x plus 1 will give me negative 5x minus 5. Oh, very nice. You see, I get a remainder of 0. Remainder of 0 means what? Show you another example. Go back to primary school. 155 divided by 5. 3, 15, 5, 1, 5. You get 0 in denominator. 0 in denominator means 5 is a factor of 155. Which means if you get a 0 in denominator, 0 in remainder, you get a 0 in remainder, means this fella here, this denominator here, is a factor of this function here. Write down for you. X plus 1 is a factor of 2x squared minus 3x minus 5. Hold on. I will tell you what does it mean later. Okay? Now forget about this one. Forget about this long division thing. Go back to your form 4. Okay, now go back to form 4. Chapter 2 quadratic equation. Solve this equation. Just press your calculator lah. Mod 5, 3, put in 2, negative 3, negative 5. Okay, so it should be 2x minus 5, then x plus 1 give you 0, x equals to 5 over 2, x equals to negative 1, right? Now combine these two together. What can you see? Do you notice that? Your C is negative 1? Your C is negative 1. F of C is the remainder. What is your remainder? 0. Okay? So this is actually, factor, that's why I think for me, I will remember factor theorem as a special case of remainder theorem where the remainder is equals to 0. Okay? One more time. Again, you go and do a long division, you get 0 in your remainder, means this thing here is a factor to the function. If that is the factor of the function, your f of c must be equals to 0. And sometimes people call it the zeros of the function. And this is your Factor theorem. If your f of c equals to 0, then x minus c is a factor of f. Okay? Then with the factor theorem, we can actually solve polynomial equation of higher degree. You see, you don't know how to solve this cubic equation, right? And in fact, I actually did a video on how to derive the cubic equation, which I don't think you want to use because it involves complex number. So because you are already given that, oh, x minus 1 is a factor. Means what? Means after you divide, you should be able to get two very nice brackets, which is equals to 0. Very nice bracket. Then you say fx equals to 0. Okay, and you know, and then when you check out x minus 1, which means this should be something x squared blah blah blah, right? And do you know how to solve quadratic equation? Yes. So we just go ahead and do the division. And this time I'll do syntactic division because I don't think I have space for how's that? Long division. Okay. Copy down the coefficient. 1, 4, 1, negative 6. X minus c. Who's your c? Positive 1. Bring down. Right. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 5 plus 1 is 6. 6 times 1 is 6. See, you get a 0. So this means what? X squared plus 5x plus 6. Means what? X cubed plus 4x squared plus x minus 6. When you divide by x minus 1, you will get quotient plus remainder over denominator, which means the whole thing is 0 and answer, right? And now multiply both sides by x minus 1. X squared plus 5x plus 6 times x minus 1. Do you know how to solve this? If I said this one, I want to let this is my fx, right? This is my fx. So this is also my fx. I let it equal to 0. Do you know how to solve? Yes. By the principle of zero products, you see, sounds so elegant. Principle of zero products basically said that if you have a times b equals to 0, then a equals to 0 or b equals to 0. Finish. B equals to 0. Just like how you solve your quadratic equation just now. A times b is equals to 0, a equals to 0 or b equals to 0. Right? So, this will just be x squared plus 5x plus 6 equals to 0, or x minus 1 equals x minus 1 equals to 0. Then you know how to solve this quadratic equation, isn't it? This is x, then 6, 1 plus 6 minus 1. Am I right? Oh no, 2 and 3. Sorry, 2 and 3. 2 and 3 plus. Okay. So x equals to negative 2, x equals to negative 3, and x equals to 1. Hence, your solution should be negative 3, negative 2, and 1. Okay. This is how you make use of the factor theorem. Okay. Okay, we still have like. Do you guys mind staying with me until maybe like 4:45? Now it's 4:45. I think I need at least like 20 minutes for the last part. Yeah, if you guys want to leave, then just leave. I don't mind. I will. I hope my moderator is recording this one, and I think I will upload our session today on YouTube. Maybe next week or whenever I sort out everything or whenever I did everything. Okay. So now we go to the last part of the chapter, which is rational function. Okay. Rational function is basically Rational function is basically a quotient of two polynomials like this, px over qx, and maybe I should add one more line, that have no common factor. I'm not sure. I don't think this is necessary. I don't think this is necessary. Okay, just like that. Just like that. Okay, it's a quotient of two polynomials. Means you have your numerator, denominator. Okay? So usually, right, for rational function, you have to take note is whenever you want to determine the domain is you cannot have 0 at your denominator. Earlier in the lesson, I told you, right, you cannot have 0 in the denominator. If not, you need to go to the positive, negative, infinity is diverged. Okay, cannot. So, just do this very quickly. Very quickly. Fx equals to 1 over x. X cannot equal to 0. So, the domain is all the x given that x is not 0. What about this? It's actually okay, right? It's actually no matter what value, you will not get 0 in the denominator, right? If you substitute in -1, -1 you square, you got +1, +1 plus 1 is still 2. No problem. So the domain is all the x in, okay, maybe you, okay, if you want to write like that, x is a real number. Okay, sorry. Or just write negative infinity. This one, for this one, you just write what? From negative infinity to 0, not include 0, union from 0 to positive infinity. Okay? Then this one, okay, first of all, you go and factor out your x at the bottom. Denominator cannot be 0, means this fella cannot be 0, or this fella also cannot be 0. Which means your x cannot be 0, your x cannot be 1. And lastly, when will this be 0? This one very familiar. I think I plucked it from the question just now. Yeah, this one. This one. It's the same, isn't it? Yeah, it's the same. So, if you put these values into this x here, you will result in 0 denominator. So, you need to avoid that. So, the domain is all x. X not equals to -3. X not equals to -2. X not equals to 1. Okay? Just a domain, just to make sure that you don't get 0 in your denominator. Okay? And what happened when your x is at these values? These values where your function, your rational function is undefined. If you go and have a look at this graph, right? Graph of 1 over x. Do you notice that we said that x is undefined at 0? Do you notice that you have a break here? The graph is not continuous at x equals to 0. Okay, so usually when you in a domain, we say that x cannot be equals to something, meaning discontinuities happen at that something when x equals to that something. So in this case, it's 0. And usually we have two types of very common breaks. The first one is vertical asymptotes, which is what you learn in your trigonometric function. You remember your tangent? It's like a vertical line that when your graph approach 0, it will go up to infinity, but it will never touch the line x equals to 0. Okay, so this is vertical asymptotes. And another one is like holes in the graph. Holes in the graph. Okay? Like this one. It's all defined. Suddenly, when x equals to 1, what happened? 1 minus 1 is 0. Cannot. So you leave a hole. So this is another type of discontinuities of rational functions. Okay? We have 15 more minutes for the last part of the chapter. And I'll let you go after we do this partial fraction. Okay, so far is everyone okay? Is everything okay? I think rational function, the concept is quite simple. Just that you need to know how to determine the domain, and you need to know what do I mean by breaks. Okay? Okay, last part of today's class, partial fraction decomposition. I'm not sure how many of you have heard of the term partial fraction. But basically, partial fraction is like these two fellow here. It's like you break a whole piece of rational function into simpler rational function. And this can be very, 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 very useful, especially in calculus, especially in integration, because obviously, I don't think you want to integrate this fellow here, right? But integrate this one, seems okay. You see, I integrate this one x plus 2, the negative one. Yeah, can, right? You can differentiate, right? But definitely, how to differentiate this one, a little bit hard. But of course, actually you can differentiate. Actually, you can differentiate after you learn some of the techniques of integration. You can actually do both. You can either direct integrate or you can break it to partial fraction before you integrate. But anyway, just for today, I just teach you how to break it into partial fractions. Okay? So this is a procedure. First thing, because you know that it is a rational function, right? You have to make sure that the degree on top must be less than the degree at the bottom. What happens if the degree on top is greater? If the degree on top is greater, okay, if not, do step 0, which is do your long division first. Do your long division. And long division, your quotient, you just leave it aside. You don't care already. You see, this one. This is not a good example. This is not a good example to explain. But you see, after you do the long division, you see, you just throw the quotient aside. Don't care about the quotient. Focus on this one. But in this case, this is already a very nice, simple fraction already. Do you notice that after you divide, after you do a long division, your denominator must, okay, this is actually your what's that? Your remainder. The one on top, the degree on top must be always smaller than the one at the bottom. Then you just go ahead, and if this is a very complex function, then you just go ahead and proceed with your partial fraction, which is what we will be doing now. Okay? So what is the procedure to do partial fraction? After you make sure that the degree on top, okay, the degree on top is less than the degree at the bottom, you can start doing the work already. And okay. So you try to factor the denominator into as many factors as possible. As many factors as possible, I mean to factor into the simplest factor as possible. Means if you can break it into linear factor, break it into linear factor. If not quadratic, if not cubic. But if you can break the cubic further into quadratic and linear, break it. Okay? So in this case, if you go and press your calculator, you should be able to factor this into x plus 2 to x minus 3. Okay? After you break it, you break it until you cannot break. Okay? Break it until you cannot continue. Then after that, you go and look at this denominator. See what kind of factor you have. See what kind of, is either linear factor or a quadratic factor. You go and just look at the factor, how many factor, what kind of factor do we have. If, basically, you refer to this table. Basically, all you have to remember is this fellow and this fellow. Okay? If you have a linear factor, this is a linear factor, right? Ax plus b is a linear factor. Then you choose this one. Then you create a partial fraction like that. A over ax plus b, where your big A, big B, your capital A, capital B, capital C, capital D are all constant. Okay? And do you notice that if the degree at the bottom is linear, right? Linear means the degree is 1. Means the degree on top must be 0. Must be a constant. Must be only constant. You cannot have like ax on top, ax plus b. No, this is not the partial fraction that we want. Okay? Then what about quadratic factor? What if you have a quadratic factor that you cannot break into 2 linear factors again? Then you have to do this one. You have to create a partial fraction like this. And do you notice that, you see, the degree at the bottom is 2. And the degree on top is, okay, I will not say it's 1. The maximum degree is 1. Because sometimes, because I told you, big A, big B, big C, big D are all constant. Sometimes your A can be 0. Okay? So the maximum degree, if it is for that partial fraction, if your denominator is a quadratic factor, on top maximum degree you have is 1. Means the most you can have is a linear factor on top. And you create that partial fraction. Okay, and yeah, this I know it's very abstract to talk like that. We just try one example here. Okay, we try one example and you know what I mean. Okay, so I directly show you what you should do here. Okay, first I already factored out the factor for you. I already break into 2 linear factors for you. Linear factor means what? Means you will create how many linear factors? 1, 2. You will create 2 partial fractions. So you let it be, okay, this is not so nice. You let it be A over the first factor plus big B over the second factor. Okay? This is like you create the partial fraction yourself. You create a partial fraction yourself, then you solve for the big A, big B. Okay? Clear? Then next, you do what? You go and multiply both sides by x plus 1, x minus 3. What happened to your left hand side? This and that will cancel, this and that will cancel, isn't it? So you have x on your left hand side, and when you multiply, this x plus 1 and this x plus 1 will cancel, and this one will go on top. A x minus 3 plus b times, I run out of colors already. You cancel out this x minus 3 with this x minus 3, so it is b times x plus 1. Okay? And now we need to solve for big A and big B, right? And we actually have 2 methods of doing this, which is the first one, the cover-up method. The cover-up method basically means, you see, when I want to solve for big A, means I want to ignore this big B. I don't want to look at this big B. How can I make this big B disappear? I cannot change the value of B because B is fixed, but I can change the value of x, isn't it? So if I let x equals to -1, then what happened? -1 equals to A times -1 minus 3 plus B times -1 plus 1. -1 plus 1 is 0. See, your B nicely disappeared. Don't look at the B already. And can you solve for A now? Yes, -1 equals to A times -4. So A equals to 1 over 4. But don't forget about your B. When you want to solve for B, you want to, okay, let me erase this one. You cover your A. You cover this one. You don't want to look at A. What should you let your x be? You want to make this 0. So you let x equals to 3. When x equals to 3, 3 equals to A times 3 plus 3. Sorry, 3 minus 3 plus B times, this one is what? X, is it? Yeah. B times 3 plus 1. So 3 equals to this. The whole thing here becomes 0. B times 4. So B equals to 3 over 4. And with that, you are done. Because you can just put in your A and B. 1 over 4, x plus 1 plus 3 over 4, x minus 3. And if you want, okay, and you should write it nicely like this. 3 over 4. And you are done. This is the partial fraction to this expression here. Okay? Is everyone okay with partial fraction? Yeah, this is another new thing to you, I know. Basically, the story is you go create the little partial fraction that you want. You create your own partial fraction. You solve for the constants. Okay, and this is one of the method, which is what we call cover method. Now I show you the second method, which is comparing coefficient. Let's say, because sometimes people say that, hey, how do I know I let x equal to what? How do I know? Sometimes very confusing. Sometimes if your this one is not just a whole number, maybe a square root or a fraction or whatever kind of bullshit. How do I know what should I let my x be? If you don't know, never mind. Okay, fine. Do the second method. Still the same procedure. You create your partial fraction. You multiply both sides by x plus by all the factors, or you multiply it by gx basically. Same thing, you will get this one. Okay, x equals to a times x minus 3 plus b times x plus 1. Okay, same story. Then after that, okay, stop here for a while. You don't know how to continue because you don't know what x value what should you let x be, right? You don't know how to continue. What can you do? Brutally go and expand the whole thing. Okay, go and expand the whole thing. Ax minus 3a plus bx plus b. Go and expand the whole thing. After that, collect all the like terms together. Ax plus bx. These are just constant, right? A and b are just constants. And then, okay, I write one more step for you. A plus b, x minus 3x plus b. On right hand side is x. And because, remember, this will always be true. This will always be true because no matter what value of x is, because you define it like that. You let it be like that. So it means that you can compare the coefficient of all the x terms. X basically means 1x, right? 1x plus 0. Okay. 1x plus 0. 1x plus 0 equals to this further here. I think you know what I want to do. I compare this with that. I compare the coefficient of x. Okay. Coefficient of x. On left hand side it is a 1. On right hand side it is a plus b. This is my first equation. One more time. If I don't know what to do, I don't know what to let x be, I brutally go and expand everything out. Brutally go and expand everything. Then I collect all the like terms together. Then I compare the coefficient. When I compare the coefficient of x, I get 1 equals to a plus b. When I compare the coefficient of x to the 0, which means the constant, on left hand side it is 0. On right hand side it is negative 3a plus b. This is your equation 2. You have 2 equations now. You have 2 variables, 2 equations. Can you solve? And it is linear some more. Yes, you can solve using form 3 maths is enough. Okay, you know what? You can solve it using any method you like. You want to do substitution also can. You want to use matrix also can. You want to do elimination method also can. But for me, I just use elimination method because I already write it like that. I will add equation 1 and equation 2 together. On left hand side, 1 plus 0 is 1. A minus 3a a minus 3a is, wait, did I get wrong somewhere? Wait a minute. Oh, I shouldn't add minus, because I realized that I cannot get rid of my b. Okay, sorry, my brain a little bit hang just now. Okay, 1 minus 0 is still 1, no worries. A minus 3 is a minus 3 is a plus 3, which means 4a. You see, b and b can cancel each other. Okay, so your a equals to 1 over 4, and you got your a. You substitute back into any one or you like. A plus b, so b equals to 3 over 4. See, you still get the same answer, isn't it? A equals to 1 over 4, b equals to 3 over 4. And you just put it back to the partial fraction that you create and write your answer. This answer. That's it. Partial fraction. Okay, it's 4:44 now. I promise to let you go by 445. So I have another question for you, and this time you actually have like quadratic factor. So good luck with that. You can try it on your own. I will send the answer after the class. Okay, so okay, anything? Okay, give me 1 more minute. Give me 1 more minute. So whenever you have repeated factor, right? You see this one is like repeated linear factor. This is a linear factor. I repeat for 2 times. You need to create 2 partial fractions. You see here, whenever you have a linear that repeats, you need to create 2 partial fractions. For a linear, I told you the degree on top is always smaller than the degree at the bottom. And the reason why you need 2 partial fractions here is to build out the power. This is what we call build out power. Because you know what? If you have like, I told you right, before you do partial fraction, you need to make sure that your degree on top is less than the degree at the bottom. So which means if this is like ax plus b squared at the bottom, your degree at the bottom is 2, right? Which means maximum you can have a mx plus c on top. I mean, you can have a linear on top. But if you only let it be this one, you only say, I lazy, I don't want to find so many constants, I just let it be b over ax plus b squared. Do you notice that you have a problem, right? How the hell in the world are you supposed to get back how the hell can you get the m? Where the hell is your x? Cannot, right? So if it is like this, okay, ax plus b squared, you need to build out a power plus b over ax plus b. Because you remember the procedure, we will multiply both sides by gx. Multiply both sides by gx, which means mx plus c, it is a times ax plus b plus b. So mx plus c equals to, I have all kind of weird thing. ax plus ab plus b. So this is the constant, this is the coefficient. So this is m, this is c. Okay? So this is the reason why you need to have 2 partial fractions for that. And I think in your syllabus you only learn up to repeated quadratic factor, and I think this is all you need. Okay, this is all you need. Okay, so with that we are done with 1.1 and 1.2. I know it's a lot of new shit for you. Do you have any question? You can ask, or you all pen already?